Swayam Prabha. Digital India. Educated India.
So, friends, in this session we are talking about material requirement planning in a course on production and operations management, and within the production and operations management we are talking about production planning and control. If you recollect, in the previous session we talked about aggregate production planning. In the aggregate production planning we will try to see that how to meet the scheduled demands with the help of production. So, we developed the master production schedule as a output of the aggregate production planning. In this session we will talk about how to use the aggregate production planning to work out the material requirements for the manufacturing. So, this is more like a material how to plan the material keeping in view the aggregate planning or production planning in view. After generating the master production schedule in aggregate planning, MRP system creates schedules of materials required to be produced or manufactured in-house to meet the MPS. So, we will create the schedules for procurement as well as in-house production. MRP determines the exact number of units, the date when needed, and then based on the lead time determines the order release dates. Material requirement planning is a computerized inventory control system. It is part of the production planning and control system. It is a management information system also. It provides it is more a information system as a software, and it is a manufacturing control system also. With the help of this, it will generate the reports with the help of which we can see that whether the materials and production is as per the plan, or if there is any deviations, or if there is any deviation in the demand also, we can create exceptional reports also in the material requirement planning. Material further we have seen the unit of inventory management also. The purpose of the inventory management is also to find out how much to purchase and when to purchase. Material requirement planning also help us in determining how much to order and when to order, how much to purchase and when to purchase. Also if it is a in-house production, how much to manufacture and when to manufacture. The difference between MRP and inventory models is, inventory models are useful for those items the demand of which is independent, whereas MRP used for those items the demand of which is dependent. Just like take the example of a pen. How many, if your demand is let us say certain unit, you need to produce 1 lakh units of pen per year. So, you have to decide what should be, how much quantity I should produce at what time. You have to produce in batches, or so you have to similarly to have to procure the material also, whatsoever material is required for this, you have to procure the material also. So, whereas you have to decide how many caps to be produced, you do not have that, the demand of the cap is not independent, demand of the cap depends upon the demand of the pens. So, the demand of the pen is independent, which is driven by the customer or the market, whereas the demand of the cap is dependent, which is driven by the demand of the pens. So, this is how we can see the concept of independent demand and a dependent demand. Independent demand, the demand of which depends upon the customer or the market, whereas dependent demand item, the demand of which depends upon the some item whose demand is independent. So, this is also a MRP useful for the complex products, just like in a car manufacturing. Several hierarchies are there. To manufacture a car, you need to have certain sub assemblies, you need to have sub assemblies, and then various components, fabricated parts and certain bought out parts, etcetera, etcetera. So, in those cases MRP is very useful technique to find out the material requirement, procurement requirement, in-house manufacturing requirements. We will use the concept of bill of materials. I will explain the concept of bill of material, that will tell you to produce 1 unit of a end product, what are the various sub assemblies are required, what are the various sub assemblies are required, and different component parts and raw materials are required. So, with the help of bill of material, we can determine a particular material or item, when it should be manufactured if it is in house, when it should be purchased if it is coming from a vendor. So, that is the whole purpose of material requirement planning. It helps in finding out the requirements of material for a dependent demand items. So, material requirement planning provides information about when to purchase, produce and how much to purchase and produce. It is useful, as I said, for the dependent demand item like tires. In a car manufacturing unit, if you have to produce 1 lakh cars, how many tires are required, or in a planning period, let us say in a next month, in a 1 month planning period, you need to produce 20,000 cars of a particular model. Then how many tires to be purchased? 5 tires are required in each car. So, you need to purchase, if the 1000 car to be produced, 5000 car tires need to be procured. So, this is how. So, there is no separate independent planning is required for the dependent demand items. So, similarly, as I gave the example of a cap of a pen. So, by definition, independent demand is directly related to customer demand and need to be forecast, whereas dependent demand items is directly related to the demand of other stock keeping unit, other independent demand items, and can be calculated without the need of forecast. I need not to forecast how many tires I should purchase. It is based on the number of cars I am going to manufacture. It is a means of determining the number of parts, components and materials needed to produce a product with the help of bill of material. I will explain you what is meant by bill of material, how it looks like. It provides the time scheduling information, when to procure the material, when to produce a particular component or sub assembly, specifying when each of the part and component should be ordered or produced depending upon the delivery schedules of the independent item. You have to, let us say, deliver on 10th of October certain number of units of car. Then based on the lead time, you will decide when I should start the manufacturing of this. Based on that, you will see that when I should go for the procurement of the components and parts and tires, etc., like this. So, depending upon the lead time, depending upon the bill of material, you have to decide that. So, it provides the time scheduling information also, that is why it is called management information system also. Dependent demand drive MRP. So, MRP is a software system also, it is a software system, and it was developed in 1960s. We will see the history of MRP also. MRP helps businesses and manufacturing define what is needed, how much is needed and when materials are needed, and work backward from a production plan for finished goods. So, if we know the dispatch date of my finished goods, from that we can work backward to find out when various components and sub assemblies are required. MRP converts a plan into a list of requirements for the sub assemblies, parts and raw materials needed to produce a final product within the established schedule. The 3 basic inputs to MRP system are master production schedule. Master production schedule is coming from the aggregate planning, and we also should have how much inventories of different component and parts is available. So, I should have inventory status files also, and third is the bill of material, structure of the product. Okay. So, 3 set of informations are required to run the MRP system. MRP calculates what materials are needed, how much is needed to build a product, when materials are needed in the production process. Okay. So, what is required, how much is required and when is required. So, that is the output of the MRP system. So, this is the output of the MRP system. Along with this output, it also produces certain other secondary reports also and exceptional reports also. So, now let us connect master production schedule with the material requirement planning. After having the master production schedule, we can go for the material requirement planning. Material requirement planning has 3 important inputs. One is the master production schedule, number 2 is the inventory record files, and number 3 is the bill of material. Okay. Now, let us see the master production schedule will come from the aggregate production plan, and also we are having certain confirm orders and we are having forecasted orders. And then from where the inventory record files will are, all the inventory transactions are recorded, and from there we will get the data status about the various materials available in the inventory. Bill of material will come from the engineering design, and there may be changes. So, what is the latest design which we are manufacturing, from that we will get the bill of materials, and from this we are producing primary reports and we are producing the secondary reports. So, these are the output of MRP system: primary reports and secondary reports, plan order schedules for inventory and production control, and exception reports, planning reports, reports for performance control. These are some of the secondary reports which are getting generated with the help of material requirement planning. So, what is bill of material? A bill of material defines the hierarchy relationship between all the items that comprises a finished goods. If A is my finished good, then what it represent? I need two sub-assemblies, that is B and C. I need two sub-assemblies B and C. 2 units of B are required to manufacture 1 unit of A. 4 units of C are required to manufacture 1 unit of A. Further, to manufacture 1 unit of B sub-assembly, I need 2 components, that is D and E. 2 units of D are required and 3 units of E are required. Similarly, to manufacture 1 unit of C, 2 units of D are required and 1 unit of F is required. So, this is called bill of material, popularly called BOM. This is called bill of material, popularly called BOM of a product. BOM of a product. This tells you that to manufacture 1 unit of A, how many components, sub-assemblies and parts are required. Okay. So, this is an extensive list of raw material components and sub-assemblies required to construct, manufacture or repair a product or service. It represents the product structure. This is a product structure. It encompasses information about all sub-component needed, their quantities are mentioned here. 2 units of B is required, 4 units of C is required. For 1 unit of B, 2 units of D are required, 3 units of E are required, and so on. So, this represents the quantities also. To produce 1 unit of A, how much material is required of different types and components. So, quantity, and this it also gives the sequence of built up. D component is required to build up B, B component is required to build up. Here we have seen only 3 hierarchy level, but in certain cases this hierarchy level may be 8 to 10 also. So, depending upon the complexity in the manufacturing of a product, this hierarchy structure can be even more deep in nature. So, and the sequence of build up in the end product, information about work centers performing build up operation is can also be included in this. You can also write out from where the at which workstation B is getting manufactured, at which workstation C is getting manufactured, whether it is a bought out component or a in-house manufactured component. Sometimes BOM also include the lead time information also. I can say that to manufacture A, 5 days are required. To manufacture B, if all the components are available, 3 days are required, something like that. So, and to procure D, 2 days are required. So, that is the lead time information can also be expressed on the BOM structure, or it can be given in another different table also along with the inventory record file. It can be lead time information can be added to the inventory record file, and it can be given in the bill of material structure also. So, this is the overview we have seen earlier. So, material requirement planning require bill of material, master production schedule and inventory files, and it will help giving us manufacturing orders, purchase orders and various other kind of reports. So, very simple setup and it is a software. You just feed the information of your master production schedule, it will generate the manufacturing orders, purchase orders, etc. You will be surprised that in 1950s, when the computer was just taking shape in the manufacturing, MRP was first computerized by Aero Engine Makers Association with General Electric and Rolls Royce. So, in the 1950s, the first time people thought about MRP and first computerized system was developed. It was reinvented with the help of a Polaris program, and in 1964 it was launched as a full fledged software and for the individual businesses. Earlier it was more a captive within the organization, they developed and using in a captive manner, but the software was made open to any individual businessman first time in 1964, and first use was by Becker and Black and Decker. Black and Decker was the first user of this MRP system. In 1975, you will see the penetration of this. More than 700 companies implemented MRP, because it was so good that you are able to plan all the materials which are required. Automobile industry is the major user of MRP because of their very deep bill of material, and so many components and parts are required to manufacture a car. So, they are the most prominent user of MRP system as their inventory management system. In 1975, the MRP system has been updated to made it more efficient for businesses, including several different models. Today, MRP is one of the most common and widely used inventory management system in the world. So, almost every organization uses MRP, and in fact, now we are having advanced also, then though it is coming somewhere in our discussion also. MRP, then it was taken a shape, it was only materials planning. Then people said that when it is so successful, why not the other resources of manufacturing, why other resources of manufacturing can be included. So, it becomes manufacturing resource planning, not only just material. Material is one of the resource in manufacturing resource planning, because the abbreviation of this is also MRP. So, this was given a name MRP 2, and 2 is also written in this manner. So, this is called MRP 2. And this was developed. So, MRP 2 includes MRP also. So, many organizations have implemented MRP 2, and in 1990s onward, now another popular system which has come, that why only manufacturing resources, why not the other resources of the enterprise like finance, like marketing, like R&D, why they should also not be integrated in this software. So, it become enterprise resource planning. So, now we are having very popular ERP systems. Almost every organization, even small organizations, have implemented. They can, if they are not able to purchase the software, they can have it on a monthly or annual subscription. So, these companies, ERP companies, they are providing the software, they are also providing the space on the cloud also to these companies. So, you can subscribe as a small scale industry, they can subscribe to ERP softwares on an annual subscription basis, and this annual subscription is also not very expensive. Along with the software, you are getting the cloud space also to store your data. So, this is a brief history about the MRP. It was established in 1964 as a commercial software available to all the users, all the industries. Let us take one example to understand how the MRP system works. So, we have taken one product structure which we had discussed in the previous slide also. So, we are having a product A to be manufactured, and it required 2 units of B and 4 units of C. Each unit of B required 2 units of D and 3 units of E. We have taken a very simple structure, otherwise it may have more width as well as more depth also. But for the sake of understanding the process involved in material requirement planning, we have taken a very simple example where we are having only 3 hierarchies in the bill of material, and not many components, only 6 components we have taken. One is the final product, then 2 sub assemblies and another 3 bought out components in this we have taken. Now, this is the bill of material we are having, and this is the our inventory status file. This is the inventory status, how much inventory we are having of different products as a opening stock. And then we also have written here the lead time data also, and the demand of the product. This is nothing but master production schedule, master production schedule. How much is the demand of item A at different point of times. Okay. Here we are consider only one period, that 75 units of A is required on day 15. Okay. Same way you can have more such kind of data on day 15 is required, on day 30 or something is required, on day 10 something is required of the next month, like this you can have that. So, very easy to work out this. So, I hope this data file is clear to you. The various input data which is required, one is bill of material, that is and then we should have inventory files, lead time data and the demand requirement or master production schedule. So, 4 set of information we have mentioned here for the purpose of running the MRP system. So, same thing I have reproduced here, bill of material is here and our input data is here. Now, this is my MRP sheet, this is my MRP sheet in the software. It will look like this. There is a demand of 75 units on day 15, there is a demand of 75 units on day 15. I am having 25 units of stock available with me. So, net requirement is 50 units, 75 units requirement minus 25 units I am having with me. So, 50 units requirement is there on day 15. So, I will add 25 which is in with my stock and I can dispatch 75 units on day 15. Now, for item A, 2 units 2 days is the lead time or 2 weeks is the lead time. If 2 weeks is the lead time, I must start this production on the 30th day. So, I have shifted this date by 2 weeks. So, order should be placed, whether it is a purchase order or whether it is a work order. Purchase order for purchased items, for bought out items and work order for in-house production. Okay. So, we can issue the necessary order, purchase order or work order depending upon the nature of the item. So, this is the first step in material requirement planning. Based on the requirement of end product and the available inventory, we should plan its manufacturing production of that by placing the work order. Now, come to the step 2. To produce A, I need B. 2 units of B is required to produce 1 unit of A. At the same time, I need 40 units of A of B on day 11 for spare market. So, B is required to manufacture A as well as to meet the requirements of spare parts also for the maintenance of this. B is required to manufacture A as well as to meet the spare parts requirements. So, first see the spare because material is required on 50th day and spare part is required on 11th day. So, let us see on the 11th day I need 40 unit to be dispatched, I am having 30 units in my hand. So, I have to place the order for 10 units. On the 11th day I need 10 units and there is a 3 days lead time, So, shift this date by 3 days and place the order, work order or procurement order on the day 8. So, on 11th day I need, though I need 40 units, but 30 units I am already having. So, I need to purchase or arrange only 10 additional units. On day 11, for that I must place the order on 10th day, because 3 days is the lead time. Okay. So, this is my step number 2 for the item B, which need to be as a spare part. Now, we will see as a step 3 for production which is required for A. Now, step 3 for the again for the unit B, step 2 was also for unit B, item B, and step 3 is for item B. 2 units of B are required to produce 1 unit of A. We know that 2 units of B are required to produce 1 unit of A. Net requirement of manufacturing of A is 50 units. So, 100 units of B are required on day 13. You have to start your manufacturing of item A on 13th day. So, on 13th day you must have 100 units of B available for manufacturing, and as we have seen 3 days is the lead time to arrange component B. So, I have placed the order 3 days in advance, that is on the 10th of day place the order for 100 units of B. So, this is my step number 3. In the same manner, I can repeat the step 2 and 3 for all other items of C, D, E and F. Let us see the item C. Item C, 4 units are required to manufacture 1 unit of A. So, I need to manufacture 50 units here. So, I need into 4, 200 units on day 13. And how much is the lead time? 1 day is the lead time. So, I place the order on the 12th day for component C. For component C, I place the order on 12th day, so that it is received on 13th day and I can easily use it. One thing we have to keep in mind here in MRP which we are working here, we are considering that lead time is deterministic in nature, demand is also deterministic in nature, and it is there also. If there is any change in the demand, that will be of A only, there will not be any change in the demand of other components, but definitely there may be a change in the lead time. So, we will discuss at the fag end of this unit the concept of safety stock for the items. Now, so this is we have worked for item number C. Now, let us see for item number D. In the same manner, item number D. Item number D is required for B as well as for C. To produce B, so where is our B? B is here. You need 100 units of B, production of B to be started on day 10. So, 2 units of this is required here to start this production. Okay. So, 2 units of D is required to produce every unit of B. So, 100 into 2 is 200, and there is a lead time for D is 3 days. So, you shift it to here and bring it here. So, 3 days you place the order on 7th day. So, that it is received on 10th day, and you can start the production of B on 10th day to produce it on the 13th day, and 13th day you can start the production of A. So, that it is dispatched on day 15. So, this is how we can see. I will explain again. Now, let us see the another requirement of D. Another requirement of D is because of C. Now, for C, if we look at C, 200 units of C need to be start manufacturing on day 12, and each C require again 2 units of this. So, 400 units are required, and 3 days is the lead time, and 3 days is the lead time. So, I must place the order of 400 units of day 9. So, this is how the requirement of D is worked out. This is how the requirement of D is worked out. Also, you need to have some spare part of B also. 10 units of B need to be manufactured as, let me change the color. 10 units of spare part of B also need to be manufactured. For that, I should start the manufacturing on day 10. For this B, I need 2 units of this. So, 20 units of B is required here also into 2, and this also I must place the order here 3 days in advance. So, for spare parts I should place an order on day 5th. For the manufacturing of B, I should place the order on day 7. For the manufacturing of C, I should place the order on day 9. So, item number D is procured on for 3 different requirements. Item number D is for 3 different requirements. One is for B, another is for C, and in B also there are 2 requirements. One is for A, another is for spare parts. Okay. So, B requirements is coming, D requirements is coming at 3 places. You are placing the order here, here and here. Okay. Now, coming in the same manner, we can discuss about the E also. E requires you need 25 units of E as a spare part, and you are already having 30 units available. So, you can work out for that. Similarly, we can work out for the so only I need to have I can work out from this 100 units are required of B 100 units of B. Let us see for item E, though it is similar, just to explain that E is required to produce B. Okay. E is required to produce B. So, I need to produce B 100 units of here, B need to be produced, and each unit required. So, 300 units is required here. Okay. Also, I need to dispatch 25 units of this. Already I am having 30 units available here. So, 5 units surplus I am having here. So, I need to produce only 295 units here only. I am not done any planning for this 25 units of spare parts, because I am already having 30 units. So, no order need to be placed, only I have to update the records after dispatching 5 units on day 5. I have to only update my records, that now I am left with only 5 units of E. So, 295 units of E is required, and lead time for this is 2 days, shift it by 2 days, and like this I can work out the order place date for the component D. Similarly, for F, 1 unit of F is required for each unit of C. So, you can work out from here like this, and from there you can work out like this. So, this is how we can develop the material requirement planning for various components and parts using the MRP methodology. It is a computer based program and it is a database program, management information system. So, in this manner, for all the 6 components and parts or final products, we can develop when the item need to be dispatched. So, trigger is coming, this is the independent demand, this is the independent demand, and rest of all demands depend upon this, and based on this bill of material we have developed the requirements and orders for various components and parts. So, very simple concept, very useful concept. Maybe if you are getting the furniture assembled at your own home, various furnitures, and it require different types of materials at different levels. Wood is required, then foam is required, fabric is required, nails etcetera is required, or some other thread and other things are required. So, depending upon that fabric and other things. So, you can develop the bill of material also, based on that you can work out when a particular material need to be ordered. Similarly, while doing the paints in our houses or in our offices, different types of paints are required for interior, for exterior, for door, windows, wooden windows, wooden this thing, steel items, different types of paints are required, and you can work out the bill of material and requirements also depend as per the time plan of the doing the exercise. So, these are more service related activities, paint or in-house manufacturing of the customized manufacturing of the furniture etcetera. So, you can work out the material requirements also in that case and in our day to day life. So, now let us see what are the various reports which are generated in MRP. Planned order schedule, obviously that is the most important report which is required. A plan of the quantity of each material to be ordered in each period. This is used to place the purchase orders to vendors and work order to purchase order to vendors and work orders to the in-house production. This also helps in updating the inventory status also. Then if there is any change in the planned order, that is also modification of the previous plan orders, this can be due to rescheduling or cancellation of the orders. So, this the change in planned order reports are also prepared by the MRP. Then there are certain secondary reports which are produced. This is the planning report to be used in future inventory planning. Based on this planning report, you can find out what is your requirements in different quarter, different months, different periods. So, you can do the advanced planning also in subsequent periods, because the demand of your product is also having a certain pattern. So, based on that you can plan for the material requirements in advance. You can do the inventory forecast in advance based on the your orders of the previous period or material requirement in the previous period. You can make purchase commitment reports also, and long range material requirement planning can be done. You can develop the vendors also, you can have long term negotiations with the vendors. Then there are performance reports to ascertain how well the system is operating. Inventory turnover ratio is very important performance measure. As we have discussed while discussing the aggregate planning also, inventory turnover ratio, if that is total sales volume divided by the average inventories, and if the inventory turnover ratio is 12, that means you are keeping only 1 month inventory, and if the inventory turnover ratio is 2, that means you are keeping 6 month inventory. So, higher the inventory turnover ratio, more efficient is your utilization of material. As 1 month inventory, and this is a case of 6 month inventory, 6 month inventory if you are having inventory turnover. So, our idea is we should the efficiency of the MRP system will be measured. This is also called barometer of the performance of a production manager or production and operations manager. More the inventory, poor is the performance. Or higher the inventory turnover ratio, better it is. Then you have to see the percentage of delivery on time and the stock outs incidences. Then we can produce the exception reports also, reports that flag the item requiring management intention. There may be too much pilferage or discrepancies in the stocks, or there may be too many late or overdue orders, or excessive scrap is getting produced in the system. So, all these things require management attention. So, we can produce the exception reports also, which need management attention. Now, in the previous example of our MRP, we have considered that if 50 units are required here. So, we were starting manufacturing of 50 units. For 50 units 200 components are required, we were procuring 200 components. For this 200 components, let us say 400 different part is required. So, we were doing 400 only. So, this type of system is called lot for lot production system, procurement system. 50 units are required, you are producing 50, 200 components are required, you are producing 200 components also. For this 400 component need to be procured, you are procuring 400 component. So, this type of system is called lot sizing policy. Okay. Another is the economic order quantity method. 200 units are required here. So, you can find out whether all 200 to be purchased together, or you can calculate the economic order quantity also. This is we have considered only single period. I will give you one example where we are considering the multiple periods. So, there you will find that we can go for lot also, we can go for economic order quantity also, or we can go for the periodic order quantity also. So, we will see 3 illustrations also in our subsequent session, that how this perform. So, again based on which particular system program gives you the minimum total cost, we can go for that. 2 type of cost are there. One is cost of carrying inventory, and second is the cost of ordering. Ordering can be purchase order, ordering can be work order, it can be manufacturing, or it can be purchase. So, 2 type of cost we will consider, and based on that we will decide that which particular lot sizing is good in a given demand data, in a given bill of material data, or in a given MRP program. And as I said, which one to use? The one which gives the least which is least costly. So, we will see that cost which consists of cost of carrying inventory and cost of ordering, and the one program lot sizing method which gives the minimum cost, we will select that. See one illustration here, just see very closely. We are having here, we have taken the 10-week program. Earlier in MRP, we have taken only 1 week program. So, here we are taking 10 periods program, and this is the net requirement. This is the net demand, let us say of component A. This is the net demand which is there, or it can be let us say for component D. So, this is the net requirement in different periods. Okay. Now, in lot for lot method, we are procuring the same depending upon the lead time. I will place the order. Suppose the lead time is 3 days, I will place the order here of 400 units, and I will receive the material on day 5. So, on material is available on day 5. So, I will calculate the inventory carrying cost on day 5 based on that when the material is available, when it is going to be used. In lot for lot, we are not having any inventory. That is the beauty or best part of lot for lot this ordering quantity, that we do not have any inventory, we are procuring only what is required in that particular week. So, our inventory is 0. How many orders I am placing? 10 orders I am placing. So, average inventory is 0, number of orders are 10, and total cost is, as I said, inventory cost plus ordering cost, and we are presuming that each order cost 10,000 rupees. So, the cost of is costing 1,000. So, my ordering cost is 10 into 1,000, that is 10,000 rupees, and the total cost of this particular ordering policy is, that is lot for lot ordering policy is 10,000 rupees. What is there? As I said, minimum carrying cost, negligible carrying cost. It is best where the highly discontinued demand. If the demand is not constant or continuous, it is better to keep this particular policy, otherwise you will end up with the large inventories. And if the purchased item is also expensive, it is better to purchase according to the requirements. So, that is our lot for lot example, where we are having 10 period demand data available with us, 10 period master production schedule available with us, and this is what we have to produce, and this is the same quantity we are producing, as the name suggests, lot for lot. If the lot is 400 requirement, our order size is also of 400 units that way. So, that is lot for lot. Now, let us see the second case or second ordering policy, that is economic order quantity policy of orders. Now, here assume that demand data we are keeping same, but to calculate the economic order quantity we have to take the annual demand. For example sake, I have taken here 40,000 as my annual demand, and we are working for 50 weeks per year, 2 weeks is for shutdown. Ordering cost is rupees 1,000 per order, and inventory carrying cost is rupees 1 per week. This is same as we have considered here. We have considered here also ordering cost as rupees 1,000 per order and carrying cost rupee 1 per week per unit. We can write per unit. Okay. So, here also inventory carrying cost rupee 1 per unit per week per unit. Okay. So, now based on we know that economic order quantity we have studied in inventory control 2D CO by CI. D is the annual demand, cost of ordering cost is CO, and cost of carrying inventory is CI. If we insert these numbers here, so we will get 2 into 40,000 into CO, CO is 1,000, inventory carrying cost is 1 per week, and we are having 50 weeks. This is annual inventory, because my demand is annual. So, I have to take inventory carrying cost also not per week, but per annum into 50. So, I have to take this, and if I solve this, I will get 1264 unit as the economic order quantity. Okay. So, I will calculate economic order quantity as 1264. Okay. So, this is how it is calculated. So, I will place the order for 1264 units. I will place the order in period 1 for 1264 unit. That requirement in period 1 is 200. So, I am left with 1064 unit. Just see closely. I have placed an order for equivalent to economic order quantity, that is 1264 units, demand of 200 units. So, left with the remaining inventory of 1064. In period 2, no order need to be placed, because I am having sufficient material available with me. So, 0 is the order placed, and 400 unit is the demand. So, I am left with 664 units of inventory. In period 3, 600 is the demand. I am left, I have no need to place order, because already I am having a 664 unit of material available. So, 64 is the remaining stock. Now, next period demand is 500, I am left with 64. So, I will place an order equivalent to economic order quantity. I will place an order equivalent to economic order quantity, that is 1264. So, 1264 plus 64, 1264 plus 64 minus 500 is 828. My remaining inventory at the end of period 4 is 64 is my initial inventory, 1264 is the order I have received, and 500 is the net requirement. So, I am left with 828 units of inventory at the end of period 4. In period 5, 824 is there, requirement is 400. So, no new order need to be placed for 428 here also. So, in this way I can work out the inventory at the end of different periods. And how many orders I have placed here? How many orders we have placed? 1, 2, 3, 4. 4 orders are placed there. So, number of orders are 4, and 4 into 1000 is the 4000 is the ordering cost. And how much inventory? Inventory is 1064 plus 664 plus 64 plus 824 plus this plus this plus this plus this plus this plus this is equal to 4972 units. Okay. So, that is the inventory, and 1 rupee is the inventory carrying cost. So, 4972 is here. So, together this particular ordering policy, the cost is 8972 as compared to the previous policy where the cost was 10,000. Lot for lot the cost was 10,000, and economic order quantity policy the cost is 8972. This is useful because it minimizes the ordering cost. You are purchasing at a economic order quantity, good for high demand items and regular production items. It is useful for high demand and regular production item, just like in a car manufacturing, the various components and parts you can order based on economic order quantity, where the demand of the end product is regular and also high in quantity. Now, coming to the third method, that is the third method of ordering, that is a periodic order quantity. What we do in this case is, we will draw from the previous case of economic order quantity. You will find that our order size was EOQ was 1264 units. So, how many orders per year, or what is the time between two consecutive orders? Time between two consecutive orders. Orders is equal to 1264 into 50 weeks divided by 40,000 is the requirement. So, this turns out to be 1.58 weeks. We can average it to 2 weeks, or we can convert it to days also, because our planning is a weekly basis. So, we will every 2 weeks we will place the order. So, you will see that every alternate week we are placing the order. And how much order? The demand of first and second period order is placed there. The demand of third and fourth period demand is placed, order is placed here. So, what you are finding here? The order quantity is varying, but periodicity is defined, that is after every 2 weeks you are placing the order, but of quantity equivalent to the demand of coming 2 periods. So, here in periodic review system, periodic order quantity system, the periodicity is a constant, that is 2 weeks, but order quantity is varying. Whereas, in the economic order quantity case, you will observe that order quantity is constant, but sometimes first period, then fourth period, then seventh and then ninth. Here the gap is 3 weeks, here the gap is 3 weeks, here the gap is 2 weeks. So, the time between 2 consecutive orders is changing, but the order quantity is constant, whereas here case the time between 2 orders is constant, whereas the order quantity is varying. So, in the same manner we can calculate no order is placed here, no order is placed here, and we can find out the inventory available at the end of each period. So, 600 units were ordered here, 200 was demand. So, 400 is the remaining, 400 minus 400 0. So, like this we can work out. So, how many orders? How many orders we have placed? 1, 2, 3, 4, 5 orders are placed in this case. So, number of orders are 5 into 1000 is equal to 5000. So, 5000 is my ordering cost. And how much inventory I am having? 600 plus 400 plus 600 plus 400 800, this 2090. So, this is 2900. So, that is my inventory. So, into 1. So, that is here. So, total cost of this system is 7900. So, this is how I can calculate the cost implications of different ordering policy. 3 ordering policies we are considering: lot for lot, economic order quantity and periodic order quantity. Okay. In this case the cost was 10,000, in this case cost is 7,900, and in economic order quantity our cost was 8972. So, what we are observing here is the POQ ordering policy give the best results. So, we can pick for this particular demand data, we can pick the policy of periodic order quantity system, where in which we are procuring after alternate weeks a demand equivalent to 2 weeks of an order equivalent to 2 weeks of demand. So, that is our periodic order quantity case. Now, so friends, now you have, I hope you have understood the concept of material requirement planning and 3 different ordering policies also. And input data, as we have discussed, are bill of material, master production schedule and inventory status files with lead time data. Now, we are considering so far in the discussion that demand is deterministic. We are considering that demand is deterministic and supplies are also, supply lead time is also, supply lead time is also deterministic. Okay. These 2 things we are considering, but we know that in real life both can be uncertain. There can be uncertainty in demand, there can be change in the demand, or there may be change in the lead time also. So, just like in inventory model we calculated the safety stocks, but in MRP system we are not using the statistical method, traditional statistical method to work out the safety stock. That may not be good because the demand is highly random in nature. Demand is highly random in nature and may be coming in discrete in nature. So, in that case statistical methods may not be useful. So, why we need safety stock? As I said, variation in demand due to end item forecast error and inventory errors, or variation in supply both lead times and quantities. There may be uncertainty in lead time, there may be uncertainty in quantities supplied by the supplier. So, what are the options available to take care of these situations? We can have fixed quantity buffer stock. We may decide that let us keep a buffer stock of 100 units for this, or we can have a safety lead time. Though the normal lead time is 3 days, but we place the order 4 days in advance. So, we will keep 1 day of safety lead time. So, that material comes 1 day early, or even if it is delayed, it will not affect my production. So, I can have a safety lead time, I can keep some fixed quantity buffer stock, but or I can increase the gross requirements also. I can increase the gross requirements also, though the 100 units are required, I may procure 120 units and keep 20 units as a buffer, or it can take care of if there is any uncertainty in quantities, if less quantities are coming from the supplier. So, you give an order. So, that all which particular policy to be used, whether fixed quantity or safety stock, depending upon the nature of the uncertainty in the, if the uncertainty in the demand, I think we should keep the buffer stocks. If there is a uncertainty in the lead time, you can keep the safety lead time. If there is a uncertainty in the quantity supplied by the supplier, then you can increase the gross requirements. So, this is how the concept of safety stock we have to keep in mind, because the environment in which we are going to operate MRP is uncertain, it is not deterministic. Further details on that, if we want, if fixed quantity buffer stock, it is a good rule of thumb, set buffer is equal to maximum demand likely in a single period. Question is how much buffer I should keep? Question is how much buffer I should keep? So, we can keep a buffer as whatsoever is the maximum, though the normal demand is 200, but you are thinking that it may increase to 225. So, keep a buffer of 25 units. Never generate orders solely to replenish the, if buffer is exhausted here, do not generate a buffer of order for 25 unit to replenish the buffer. Suppose you have decided to keep a buffer of 25 units and this buffer is exhausted here. So, do not place a separate order for this buffer. Whenever next time you need a 300 units, so add this 25 units here and create a order for, generate a order for 325 units. So, never generate an order solely to replenish the buffer stock. Then we can see the safety time, how to keep, simply order early, 1 day early, 2 day early, or you can distort the lead times and priorities. This is better than buffer stock, because in the buffer stock you are not here, you are keeping the extra material only for a 1 day or 2 day, but if you are keeping the buffer, you do not know when this buffer is going to be used, because the demand is highly infrequent in nature. So, it is better to keep the lead time buffer as compared to the stock buffer, but again depends upon the situation, we cannot generalize that also. It is better if you are making the purchases outside the company, because there the flexibility is less. If it is in house, you can increase or decrease the production in between also, but if it is a outside purchase order procurement, then it is better to keep the safety lead time buffer. Then you can increase the gross requirement also, as we said, should be done at the end item level only. You can final dispatch item, do not keep it for the intermediate item, because if any intermediate item you have kept extra, it will not going to serve unless all other components are available. So, components available in match sets, because the components should be available in match sets and safety stocks are not duplicated at different levels. So, in that context we should keep the gross requirements with respect to the product which is having the independent demand. Further, we have to keep in mind that though we are placing the order, it is a weekly plan, or like in this we have worked out for a 10 period, when this need to be for 10 period we have worked out the orders to be placed, okay, 1 to 10. But obviously, all this 10 period demand which we are giving, order which you are giving, they are not confirm orders. We have to keep in mind, maybe the first 2 periods are frozen, another 4 weeks are moderately confirmed and remaining 4 are flexible. You are just giving the indication that in period 7, 8, 9, 10 I may need this, but I will revise, I may revise also, and I will freeze only 2 weeks in advance or 2 period in advance. Coming 2 periods are frozen. So, this is how we take care of any uncertainty in the demand, by freezing only, though we have prepared the 10-week schedule, 10-week orders also, but 2 weeks are frozen, another 4 weeks are moderately firm and another 4 weeks are flexible. So, this gives the window to the suppliers also to arrange the material, for the manufacturing and sub assemblies also to arrange the material and to reactivate their manufacturing systems, whether it is other resources, machine equipment, etc. Now, let us have a look at the manufacturing resource planning, though I have given the indication, is an integrated information system used by businesses, is evolved from the material requirement planning by including the integration of additional data such as employees, finance, R&D and marketing also. You have you can have data from other manufacturing resources also. MRP2 evolved from the early material planning system by including the other manufacturing resources, like your employees and the financial needs also. This system is designed to centralize, integrate and process information just like MRP. MRP, it is also centralized, integrate and process information system for effective decision making. This can be used for scheduling, design engineering, inventory management and cost control also. So, other resources of the organization. This enables the visualization of full production schedule and resource allotment. MRP2 software provide interactive schedule visualization, displaying data as stock profile graphs and capacity usage graph. Changes made on these graphs are automatically reflected on the master production schedule. So, very good management information system. MRP has master production scheduling, bill of material and inventory tracking. MRP2 also need information about machine capacities, demand forecasting, quality assurance and general accounting. These features are also included in MRP2. It helps in minimizing the inventory in the company. It also reduces the inventory management cost. It reduces the spoilage and material waste. It minimizes the production, another important resource, manufacturing machines and human resource. It minimizes their idle time. It lower the production cost and improve the on time delivery. So, these are the advantages of manufacturing resource planning. And manufacturing resource planning is further updated by including the other resources of the enterprise in the form of marketing, in the form of sales, marketing, finance and human resource. In ERP system, this MRP module is called materials module or inventory module. It has MRP has become one of the modules in ERP. So, the goal of ERP is to plan and monitor all resources of a manufacturing firm, and ERP can also have a facility of simulation also, where you can perform the what if analysis. If the demand changes, then what happen, if there is a change in the manufacturing resource, then what will happen, and you can generate the scenarios also. So, friends, our next unit is going to be scheduling and sequencing, and so, in this session we have talked about material requirement planning, how this is useful in placing the orders, what components and materials are required, in how much quantity they are required and when they are required. All these things have been integrated, and further just keep in mind that MRP is used for items the demand of which is dependent on some other parent item, just like in a car manufacturing system, the demand of various casting, various engine parts, various other components, fuel tank, seats, tires, etc., is dependent on how many final car you are going to produce. So, a very good software developed in 1964, made commercial in 1964 and further evolved as MRP2 and then ERP. And then further ERP is further evolved to e-supply chain management, where not only the enterprise resources are integrated, but the resources of your vendors, resources of your distributors and customer side are also integrated in one single platform, which is called e-supply chain management. So, you will study this in supply chain management subjects, where end to end all, not only your own enterprises, but supplier and supplier of supplier, customer and customer of customer, all are integrated together as one system, and that is called supply chain management. So, with this we have a good idea about production planning and control as a intermediate activity for aggregate planning and material requirement planning we have discussed in this particular unit, and in the next unit we will talk about scheduling and sequencing. Thank you very much.